Today, we're going to be looking into my 4 golden rules of SQL indexing and what I've seen with some of our clients' SQL databases. I'm Matt Grace, Managing Director at Flying Donkey. Let's get into it. Rule number 1, every table must have a primary key. This is without exception that every single table in your SQL database must have a primary key. Generally, this single column will be an ID column and will be a type of numeric value. You can set this to an integer field, though I have seen in some client implementations where the integer field ran out of value and they needed to change it to a BigInt. So if you do want to future-proof your application, set this column to be a BigInt. This index is commonly, but not always, set to be the clustered index. A clustered index tells you which order the records are written onto the disk. If there is another column that is better than the ID to be a clustered index, then feel free to set this other column. An example of a better column than ID, which is an order increment, to be a clustered index, could be date. This lets your rows be ordered by date in your table, and they're easier and faster to query. For this first rule, it's really about having that ID field as your primary key index and looking at your clustering second. Rule number 2, the order of the fields on an index is very important. What I mean by this is how your data is shaped in your table really determines the order in which they should go into an index. Let's take an example that we've seen with one of our clients, a log table. A log table is a very common table in many databases and generally has an ID field, a log type, a date, and potentially some other fields to store various information. If we think about the most important fields to segregate the data, date becomes very important. Generally speaking, logs are entered on a daily basis, and therefore they can help split the table into smaller tables when it is queried. Therefore, if you are setting an index on a log table, I'd recommend that you set the date field to be your first index, followed by possibly something like log type in order you to split the table down very quickly. All right, rule number 3, 6 to 8 indexes. This rule is more of a guide than a hard, fast rule, but 6 to 8 indexes in my experience is about the sweet spot on where you'll get your best performance in writes and your best performance on your reads. Now what I mean by this is every time an index is created, effectively a small side table is created off the table to store that index and all of its included fields. So when a new piece of data is written to a table, then at the point when it's being written, that smaller table also needs to be updated. If you had 100 indexes, that would mean there's 100 of these little small tables off the side that need to continually be written and updated. That means your write times will go through the roof. On the converse, obviously, if you had 100 indexes, your read times will most probably be good. So it's about trying to find a balance between good write times and good read times. And in my experience, around 6 to 8 indexes is the golden spot. On to my 4th and final rule, single field indexes are generally useless. Generally, single field indexes are useless, and unfortunately, I come across them far too often. If you are going to use a single field index, make sure it's on a data table that's not going to get too big, and also that you put extra columns into the include portion of the index so that it doesn't have to seek on the table. To go into this into a little more detail, the include section of an index puts the other values in that index into the smaller index table. If you go back to my log table example, we have log ID, type, date, and description. Let's say we set a single index on date. So we are querying, we select all where the date equals a certain field. We're going to trigger the single field index. Now the problem here is that if there is no log description in the include section of the index, the table actually has to go and scan the full table in order to retrieve all of those log descriptions. And this effectively makes that index useless. So a better index here potentially would be log date, log type with log description in the includes field. Therefore, this query could go directly to the table, directly to the index, and pull back all the values without having to go back and seek on the individual table. I will preface this by saying I generally don't see select statements with a single where condition. Generally, there is multiple where conditions. For example, log date and log type. Now, while SQL will use these single indexes, having to use multiple single indexes really hampers performance. And it'd be much better in that case if there was a single index with 2 fields and the select fields in the includes. This will really give you much better performance on your indexes. This concludes my 4 golden rules for SQL indexing. Now, these are very high level generalization rules, and I try and keep to these in principle, but SQL does have a lot of underlying data which shows you how indexes are used, how they're scanned, how they're inserted, which you can use to be more specific as to which indexes you want to run and use. I do plan to make future videos and posts about this, but these become more complex in nature and more specific to your situation. If you'd be interested in learning more about this SQL indexing, feel free to reach out and ask us any questions. We'd be happy to assist you in making your SQL databases perform better.